So in this chapter, we have done the derivative of trig functions and the derivatives of exponential functions. And this lesson, we are going to do the derivatives of logarithmic functions. And we know that logarithmic functions is the inverse of this y equals e to the exponent x. And if log base is e, we call it natural. It's just ln x. So we want to find the derivative of this one, and we know the derivative of exponential functions, so we want to rewrite it in exponential form. So this is exponent equals log base to the power, so the power will be equals to the base to the exponent. So exponent equals log base to the power, and in the exponential form, power equals base to the exponent. So this is a y. We write it in the power equals base to the exponent. Then we are going to do the derivative to both sides of this one. So we do the d over dx to both sides. So d over dx to x is 1. And d over dx, we do the 2 layers. So to the exponent e first, then do the y to the derivative to x second. So e, it won't change. Then we do the derivative dy over dx. So this is chain rule. Then we solve for dy dx. It will give you 1 over e to the exponent y. And we know that e to the exponent y equals x. So we change this one to x. 1 over x equals dy over dx. And we change the dy to y equals ln x. So this one is proved. You don't have to know how to prove it, but I think this is a interesting proof. So I want to show you. It's just go back to exponential. We know how to do exponential. And also here, we didn't do this derivative to both sides before, and this could be used for implicit. We call this is implicit equation because y is not isolated by itself. And we do the derivative to both sides, and this one, if you understand this one, you know how to do the implicit functions derivative. So you just do the derivative to both sides, and when you have the variable y, you do the derivative to y, you have the derivative of the function to x. Okay. And this method could be applied to the related rate. Related rate, it means we do the derivative not to dx, but we do the derivative to, for example, to time to both sides. So if we do the derivative to time to both sides, then we have dx over dt equals ey, then dy over dt. So if you have an equation with x, y, they are functions of time, you could do this to find the related rate. So this one we call related rate. Both implicit function derivatives and related rate are not required in this course, but it's very useful. The professors at university, they may think you know these two already, so it's better for you to practice on these two. I have links on D2L on our course homepage, and you also could search YouTube for implicit derivatives and related rate to learn how to do those type of questions. Okay, not required, won't be tested in this course. Okay. So now we have this formula for the derivatives of logarithmic function. ln the natural base logarithmic function x, derivative is just 1 over x. So this is how you can derive it, but we don't require you to do the proof. So if function f of x equals ln, now it's not only 1x, it's a function g at x. Then we do the chain rule. We do the ln first, then do the g at x second. So ln give you 1 over. Then we do the g at x derivative again. So now we are going to apply these two rules to find the derivative of logarithmic functions. So this one we have multiplication, so all the product rule, quotient rule, chain rule applied here. So this one times u prime v plus uv prime. So y prime equals x prime is 1 times ln x plus x, then ln x derivative is 1 over x. If you like, you could simplify it further, or you could just 1 times ln x is ln x, x times 1 over x is just x divided by 1. If no denominator, denominator is 1. Then x times 1, numerator times denominator times x divided by x give you 1. So this is a first derivative for the question A. The derivative for question A, then question B. This one, we need to find the order to find the derivative. So ln here first. We keep others there. Then after that, we do the derivative to this one. This is a polynomial. Then plus another one, exponential. Exponential one, you have the exponent, not x, but it's a function of x. So you have a chain rule here. So 1, 2, 3, 4. 4 derivatives. Y prime equals ln derivative is reciprocal. X cubed plus e to the exponent negative x. Then do the derivative to x cubed is 3x squared. So this is a time to the numerator. Then plus do the exponential e to something it is itself. Then to the exponent is a negative 1. So this is multiplication. Then bracket. You don't have to simplify it. This is done. Then we continue to find the derivative to the bottom one. Example 2. So this one, we are going to label it ln first. Then this part is together is u over v. Okay. So y prime equals ln is reciprocal of this one, reciprocal flip, square root x plus 1 over x. Then do the derivative to the quotient, denominator squared. Then first come first derivative, x derivative is 1 times denominator, then minus u times denominator derivative. Square root we could think is x plus 1, 1 over 2. So do the degree to the front, then degree minus 1. Then derivative of x is 1. Then it's done. You don't have to simplify it, okay? You don't need to. And then this one, we have 1, 2. And this one is tricky because this is not a explicit function. So we want to write the x, get rid of the absolute value sign. So when x is positive, it will be absolute value sign equals itself. X value is distance from that point to 0. So x positive From positive side, if it's 3, the distance is 3. And if we just, for example, if we have a -2, the distance from -2 to 0 is +2, so it will be opposite. Then based on these two, we need to do the derivative separately. So y prime or dy over dx. When x greater than 0, the derivative of ln x is just 1 over x. When x less than 0, the derivative for this one is flip it, -x, then also do the derivative to the -x is -1. So actually they are same. It will be 1 over x. Then the last one, we need to see which one we do first. From outside, then do the inside. So ln derivative c dy over dx is reciprocal first, then times cosine derivative is negative sine x, then it's done. So this is a practice on finding the derivative to the log. Then example 3, find the equation again. So you will see each lesson we want to do the derivative, then find the equation of the line tangent, and sometimes we also find the maximum minimum point where x equals 1. So in order to find these ones, find the slope, then find the point, then find the b. mxy sub in, then find the b. So we do the derivative to x. And this is u over v quotient rule. So v squared. Then u prime v minus u v prime. So common mistake is, be careful, this is minus. Then u prime, this one prime is ln first, then x squared second. So this one will be 1 over x squared first, then times x squared derivative is 2x, then write a v here, so 2x again. Then minus, copy the v here, then do the derivative to 2x is 2. Then we sub in x equals 1 to find the slope. So 2 times 1 squared, 1 over 1 squared, times 2 times 1, 2 times 1, minus ln 1 squared, then times 2, equals 2 times 1 squared is 4. 2 times 1, 2 times 1 is 4. Minus ln 1, so this is one term. Ln 1 give you 0. Times 2 is 0, so m is 1. Then we sub in x equals 1 here to find the y value. So x equals 1, y equals ln 1 squared divided by 2 times 1. We have ln 1 is 0, give you 0. So we are going to sub mxy, m equals 1, x, y equals 1, 0. This is a point into the straight line y equals mx plus b slope intercept form. So in this equation, 4 variables, 3 given, we can solve for the last one. So y is 0, 1 times 1 plus b. In order to isolate b, we want to move the number to other side. 1 times 1 is 1. Move it to other side is minus 1. So negative 1 equals b. Then we write a final statement, sub m and b into the equation. So y equals m is 1x. mx, then plus b minus 1. So this is equation of the line of the tangent line. Then we are going to see more examples. So this time we want to find if the base is not e, then what happened. So this is given, but you could write it as we have this one is the y value, y equals log b to the exponent x. We could write it by changing the base to the natural base, ln x on ln b. Then we know the derivative of this one. The ln b is just the constant. We just need to find the derivative of ln x. So it will be 1 over x. Then that is times the denominator together, you have x ln b. So this is our equation for the log that is not natural number, not e. So this one, we have u times v. Derivative is u prime v plus uv prime. So y dy over dx equals x derivative is 1 times log base 10x, then plus x times this derivative is 1 over x, and also times the ln, then with the base. So this is done. And this one is a composite of functions. So we are going to see this one. We do the cube first. So we need to rewrite it as log base 2. The power is x cubed plus e to the exponent negative x. Then the 3 is the whole thing to the power 3. So when we do the derivative, we are going to do the exponent first, then the log second, then do whatever inside this power polynomial function and also this exponential function. Okay, so question B, dy over dx, the power 3, take the degree to the front, then we don't change the base, just copy the base here. Then degree minus 1. Then times, second one is log. Log is a reciprocal of the power, then times ln natural base, then the base that is not natural number. Then after that, continue to the power. So this one, x cubed is 3x squared. The base is e, not change. Then we have another one is exponent, which is not x, so it gives you negative 1. Then it's done. So this one, find the value of g prime at 2 for this function. Okay, so for this function we have multiplication here, so we do the uv prime first. Then after that, this first one is just a polynomial. You just do the degrees to the front and degree minus 1. For this one, we need to do the log first, then exponent, the degree 1 or 2 second, then whatever under the radical sign. So now we are going to do the g prime of x equals x squared first is 2x. Then copy the v here. then plus u stay here, then derivative to log first. It is reciprocal of the power x squared plus 21, and don't forget it's log natural number base, and the base is not natural number. Then continue to do the log to the square root. So it will give you, I will write it closer to give me more space. So this is ln 3, then times square root is 1 over 2 x squared plus 21, 1 over 2 minus 1 give you negative 121, negative 1 over 2. Then x squared plus 21 derivative is 2x. Then this is a derivative to g prime x. When x equals 2, we sub in. G prime 2 equals 2 times 2 log 3 square root 2 squared plus 21, then plus 2 squared 1 over 2 squared plus 21, then times ln 3, then times 1 over 2 squared plus 21 bracket negative 1 over 2, then times 2 times 2. Then simplify this one. 2 times 2 is 4 log 3. 2 squared plus 21 is 25. 25 square root is 5. Plus this is 4 times 1 over, this is 5 ln 3. Then 1 over 2, this one will be 1 over 5. Then times 4. Continue, simplify. 4 log base 3 to the power 5 plus numerator times numerator is 16, but also you could cancel one of the 2 as a common denominator from the numerator and the denominator. So this one 4 we could consider is 4 over 1. Then all the numerator times together is 8. All the denominator times together is 25. Then use your calculator, you will find out roughly it is 6.15. So that is a question for this one. And another thing that I didn't give you this example here, but it's interesting to see. So what if? So this is extra. What if you have y equals x to the exponent x? We are not able to use power because the base is not a to the exponent x, and also is not x to the exponent a. Both are variables. We don't know how to solve this one. So how we can do it? We could change it to the logarithmic form. So the exponent equals log base to the power. Then we write this one as the same base ln y or ln x. Then we move the ln x to other side. We have x times ln x equals ln y. Then we could use a derivative to both sides to find the y prime. So our goal is find the dy over dx. So this is actual because this is interesting question. It's not required. So do the derivative to x to both sides. Then this is a multiplication. We know how to do it. So u prime is 1. plus v prime 1 over x equals this one. We do the derivative to ln first, then do the y second. So ln is 1 over y, then y derivative to x is dy over dx. And in order to solve for this dy dx, we isolate this one. We move the y to other side by multiplying the y to other side. So y times ln x plus x times x over 1 over x is 1 equals dy over dx. We don't want to see the y in the left side. We sub back x to the exponent x here. Then you have the derivative y to x. So this is just interesting to see how you can do it. So you are not able to use this exponential rule or the power rule because this a must be constant. This a must be constant. You cannot have variable at both base and the exponent. Okay. And today's assignment work is on Delta Math 5.3. So what we have done in this lesson is we have the derivative to the logarithmic function is 1 over x, the reciprocal of 8. And if the base is not e, then we have the ln b at the denominator. Then we have find also we explored how we can solve some question that is not exponential function, not polynomial function. We could change it to logarithmic function, then do the derivative to both sides to find it. And this method is implicit derivatives of the related rate you can use. Thanks for watching.